All right, as a quick review on transformations. Before I even start the first one, before I even start that one, I'm going to zoom really far in and just use like a extra little bit of space. And if you are doing this on paper, may I suggest you walk up here and get the graph paper. It's in the very top bin if you're doing it on regular paper. Use the graph paper because that's what we're doing today. Just a quick transformation review. If we have a vertical transformation, vertical, that means we're going to have some sort of parent function. And we will have plus or minus some number on the outside of the function. If it's a vertical transformation, it's going to be on the outside of the function. The function could be x squared. So x squared plus 9 would be vertical. X squared minus 2 would be vertical if it's on the outside of the function. And then does anybody remember about the common sense part if it's vertical? Is it common sense or not common sense? Common sense. So let me throw some examples in there. Example could be x squared plus 2, x squared minus 9, or maybe a negative x squared. All of those are outside of the x squared. So then we have horizontal. For horizontal, we have a function, but there's stuff happening on the inside of the function. So I'm representing that this is on the inside by what? Writing f of x plus or minus some number h. So you see how that's in the inside of the parentheses. What do I write next? Oh, parent function. So I'm writing inside parentheses. But remember, when I say parentheses, if we have absolute value bars, those are parentheses also. If it's inside the parentheses, it's going to be horizontal. Since that one's not vertical, this one's the not common sense. I'm going to write opposite. It's opposite of common sense. So if I have something that is horizontal, could be absolute value of x plus 4, or absolute value of x minus 3. Those are horizontal. And remember, horizontal goes left or right. So with this x plus 4, which direction does the plus 4 go? To the left, because this is the not common sense. This is opposite of what we would think. So this one's going to go to the left 4. How about x minus 3? Where's that going to go? To the right 3. So very quick summary of what we've done so far. The one thing I didn't talk about up here, I mean, I put it up here, but I didn't talk about it. What does this negative do? What does that negative right here do? What does that negative do? Yeah, and thank you for using that really good vocabulary. This reflects it. And we've only learned about reflecting it vertically right now. We haven't even talked about horizontally. So right now it's just reflecting vertically. I just wrote reflects vertically. Okay. So we are going to graph these using transformations. The first thing we want to do is determine the parent function. So f of x equals x plus 4. What is the parent function? For f of x equals x plus 4, what's the parent? Ada? So linear is its family name. That is correct. That's not what I'm asking, but that is the family name. So for a linear function, what is the actual rule? What's the equation? F of x equals just x. Okay, that's the parent. The parent's baby is x plus 4. So now let's talk about transformations. From the parent to x plus 4, what transformation happened? Who's being my helper over here? Oh, Maddie, what were you saying? Okay. We need to decide if it's vertical or horizontal. If it's horizontal, which is what you're telling me, it's going to be in parentheses. Do you see parentheses? No. So this is either vertical or horizontal. What is it? Out loud. Vertical. It's vertical. So my choices are up or down. With vertical, it's common sense. So which way should we be going? Okay. We're going to use fancy vocabulary that says translate up 4 units. Okay, so to do this, we need to know our parent function points, which are really easy. So x's, -2, -1, 0, 1, 2. Y's, well, the y's equal x, so -2, -1, 0, 1, 2. My parent function points for linear just go straight up the middle diagonally. 1, 1, 2, 2, 0, 0. Those are my parent function points. To do f of x plus 4, we need to go up 4 units. So we got 2 options. We can literally count every point and go 1, 2, 3, 4 and put a new dot. Every point up 4 units. That's one of our options. We know it's supposed to be a line because we already determined it was linear. So when I connect it, I make sure it looks like a line. So that's one option of getting those points, just plotting them up 4. Now my other option, which is going to be more important later when we get into more complicated transformations, is in our table. Because I know it's going up 4, up is vertical, and vertical is the y values, I can just add 4 to each of these y's. So -2 plus 4 is 2, -1 plus 4 is 3, 0 plus 4 is 4, 5, 6. And then the ordered pairs that I would graph would be the original x's and the new y's. So -2, 2, -1, 3. 0, 4, 1, 5, and 2, 6. When I make a transformation table, I don't really write the ordered pairs out because I just like look here and here, but I wanted to make sure you guys were seeing what ordered pairs I'm seeing in the table. Okay. All right, so let's do another one. We've got g of x equals absolute value of x plus 2. So the first thing I need to think about is what is its parent function? So I've already said the family name when I read it out loud. I said the family name. What's the family name? Sterling, what's the family name? Don't know. Hold on, I was asking Sterling. Sorry. No, don't know. Okay, so can you read to me that equation? G of x equals?
X plus 2.
You're missing something. What are these? Starts with an A. BS. ABS. Let me forget. You forget?
Yeah.
Okay, so what is it, Maddie? Absolute value. So the first thing you need to know is that this is absolute value. So when I read it, I say absolute value of x plus 2, and now I know it's absolute value. So then what is our parent function? Daniel, can you tell me the parent function?
G or x plus 2.
So absolute value of x plus 2 is this function. But what is the parent? The one with no plus 2's in it.
Dx equals x. Absolute value of x.
Absolute value of x. That's correct. And then I just always call the parent function f. So you can call it g if you want. It doesn't really matter. Just so you know, I just always call it f. So that's the parent function. So now what transformation has happened to change just absolute value x into absolute value of x plus 2? Is this inside or outside? This is inside, right? So if it's inside, my choices are, well, it's horizontal. So my choices are left or right. But I remember something else about horizontal. It's the opposite of common sense. So Adam, which way is this going to translate? Left 2 units, right? Okay. So then what we're going to do is we'll just plot our parent function, and the points for the parent function are the absolute value of x. So -2, -1, 0, 1, 2. I can input, but when I get it out, Kendall, what does absolute value do to numbers? Kendall, if I put in -2, it makes a positive. That is correct. Can somebody open that, please? Thank you. So all of my answers will be positive when I plug them in. Hi.
You knew I was here.
So did everybody else. So we just thought you were skipping. No, we didn't. I just figured you were somewhere. Yeah. Okay. So now from here, I'm just quickly plotting these absolute value points. They go right in the center, and you guys have to do an absolute value for your name graph. So we got to make sure we know how to do this. You get right in the center. Now this transformation says to the left 2 units. So I can take my transformation color and just move each of these 2 units left. And since its absolute value has to look like a V, I will make sure that when I connect those points, it looks like a V. And then using the table instead of using the graph, you're fine with just using the graph. What I did, that's the easiest way, less amount of work, totally do it that way. But eventually we're gonna need a table. So what I do for the table is I go to the X side, which is the horizontal side, and to do left 2, I have to subtract 2. I have to go left 2, I have to subtract 2 from all of the X's. And then my graph would be -4, 2, -3, 1. So it would be the outside X and the outside Y. Now, as you guys are writing this down, I teach pre-calc. Guess what they're doing in pre-calc right now? Reviewing all of this that they learned last year. All right, so the next one is more of a challenge. Thought we'd put a challenge in here for the notes. So we need to talk about the parent function first. And to talk about the parent function, you might need to remember the function family. This is vocabulary you have to know. Anna, please take out your, thank you. This is vocabulary you need to know. Darren, do you know the parent function or parent or the family for this? Yep. Do you know what that's called? The family name? Do you remember? Quadratic, yeah. So that's our parent function. And transformation. And I'm going to write transformations because there's actually two. Maddie? Yeah. So you know what? I'm going to write something that sounds so weird and I can't stand the way it sounds, but this is really how you say it. You say reflect in the x-axis. And you know what? It totally means reflects over the x-axis. But for some reason, they decided this is the proper way of saying it. I don't know the history of the words. I'm better at math. So it has a reflection in the x-axis. That means it has a vertical reflection. And then it also has something else. What's that -1, Megan? It does. It translates down 1 unit. And the reason why it's down is because there's no parenthesis. If there was a parenthesis, it would be left or right. If you guys are sitting in the middle, unfortunately, like the middle's always like lined up perfectly with my board. If you need to like move your seat a little bit, please feel free to move your seat or take that seat or take that seat or take a Marion seat. He's not here right now. Okay, so the parent function points for this one, we wrote in our notes the day that we were talking about parent functions. It's still -2, -1, 0, 1, 2, but I like to put 3 in there because this one's a little bit more complicated, so I like having more points. I'm not judging you if you like less points, but I like having more points. And this is a parabola. It's the U shape. And so when I connect it, I'm just going to make sure it looks like a U. Oh, I'm not going to connect this one. I'll connect the real one. But when I connect it, it will look like a U. Okay, so this has a reflect and then move it down 1. So I can't totally, I can kind of sketch this on here, but can you guys imagine like these dots reflecting first? So just flip it down. And then from flipping down, then we move it down 1 unit. So this center point that was at 0, 0, when I flip it down, it's still going to be at 0, 0. But then I move it down 1 unit, it will be here. So this one at -1, 1, when I flip it down, it'll be at -1, -1. But then I move it down 1, it'll be at -1, -2. So this one starts to get a teeny bit more complicated to do without a table. So I'll show you how you can do it with a table also, if this way is complicated. But you can do it, just flip it. So this one's like 4. So we'll go 4 this way and then move it down 1. So you can do it that way. Using the table, you have to follow order of operations. Both of these are vertical. Both of them are vertical. And vertical is Y. So on the Y side, you're first going to change them all to be negative. You're first going to flip them all. And I do that by multiplying by -1. And then after I multiply all those numbers by -1, I take those numbers and I subtract 1. So then I become -10, -5, -2, -1, -2, -5, -10. So then from there, I can get these points. Instead of just trying to figure them out on the graph, I can actually get the ordered pairs 3, -10. -3, -10, -2, -5. So I can get those by using my outside numbers. You don't have to write these ordered pairs. I'm writing them so that you can see where I found them in my table. So those are those outside points. Okay, and then the very last one, what'd I do? Another absolute value. I gave one with like lots of stuff happening. So we've got another absolute value. So our parent function is f of x equals absolute value of x. Transformation-wise, does anybody see any of the transformations in this one? Can I call on somebody or should I just randomly pick you? All right, Ryan.
The graph would translate down 5 and left 3.
Ooh, you gave me 2. You overachieved. Yeah. So Ryan said he's using this out here, saying that it's going to translate down 5, because that one is vertical, so it's common sense. And he said something 3. What number did you say, though? What, left or right?
I said translate left 3.
Okay, so left 3 is incorrect because this is horizontal. And negative makes me want to go left, but we got to do opposite of our common sense with horizontal. So that minus 3 is actually going to be right 3. So there's our opposite common sense part. There is one, oh yes, Frank.
But wouldn't it be a positive or not a subtraction sign, but addition sign because it's an absolute value?
Good question. You can't do the absolute value until you plug something in for x, and we're not doing that. So we're just looking at this in a different way. We're looking at it, what will that minus 3 do to the graph? And it will move the entire graph to the right. So don't worry about what the function is. That's not going to affect your answers ever. What matters is if it's inside, we go opposite what you see. There is one more transformation. And I don't think Maddie's the only person that knows it. Leah. So reflect. No, the x-axis is correct. I know it sounds weird, right? I'll show you why it's that. Reflect in the x-axis. So that is a vertical reflection because that's all I've showed you so far. If we have an x and y axis and we've got some cute little heart right up here, see that cute heart? No, I just made it messy. If I reflect in the x-axis, that means reflecting over the x-axis. That is going to be a vertical reflection. So like you want to say y because you're thinking it's vertical, but it actually is flipping over the x-axis. Okay. All right. So our absolute value points, I've already wrote them above. I'm not going to rewrite them because they're already on here. But they're like 0, 0, 1, 1, 2, 2, and then negative 1, 1, and negative 2, 2. We have to move this down 5, right 3, and flip it. Down 5, right 3, and flip it. So I'm going to count 1, 2, 3, 4, 5 to the right 3. And then if it's that center point, when it flips, it's still like you can't tell. The next one, if I move it down 5, 4, 5, right 3, then it has to flip. It's going to end up here. I'm going to draw where it is going to end up. And then I'll, again, maybe I should put those down. I'll do it on a table also, because sometimes when you've got all these things, it's just easy to use a table. So to do this properly in a table, we would first multiply by negative 1 to the y values because we're doing a vertical reflection. We always multiply before we add or subtract. So that if there's multiplication, that has to come first. We flip it first. Then we would minus 5. On the x side, we would add 3 because it's going right 3. And then the ordered pairs I would graph would be 1, negative 7. So at 1, down 7, and that is what I graphed. 2, -6, 2, -6. 3, -5, 3, -5. 4, -6, 5, -7. So you can see those line up perfectly. So your assignment, you've got 8 questions like this, and you have to figure out the transformations, okay? You also have to have your rough draft for your name graph done tomorrow. So if you have questions on that, I can help you in class. You're going to use your class time right now to either work on your new assignment or to work on your name graph, okay?
Is this a rough draft?
That is your rough draft, yeah. Yeah, the rough draft